When you think about the element mercury, you probably think of those thermometers with the red bar that rises when it's warm and falls when it's cold. These thermometers actually don't contain mercury at all. That red bar is made of clear alcohol that is dyed red so you can read it, and they were created to replace their slightly more dangerous relatives, which did contain mercury. The closest mercury to you right now is probably in your own or someone you know's silver dental fillings. But don't worry, this mercury isn't harmful, for reasons we'll get into later. Mercury is released from two types of sources, natural sources and anthropogenic sources, or those originating from humans. Natural sources of mercury include volcanism, hydrothermal vents, and erosion of mercury-containing rocks. Burning biomass releases mercury, but this could be a natural or anthropogenic source depending on the situation. Anthropogenic sources of mercury include mining, burning fossil fuels, and gold purification. Plenty of mercury is not harmful to your health. Whether it is or not depends on if the mercury is labile or stable. The stable form of mercury is trapped within a chemical structure like the mineral cinnabar or the dental amalgam used for fillings. Mercury in these forms are not labile, so even if you swallowed a silver filling, your body would not be able to absorb any of the mercury it contains. Labile mercury, on the other hand, is prone to chemical transformations. When we consider sources of mercury, we are considering the labile forms, which can enter the natural environment. From here, labile mercury can become bioavailable, meaning it can be absorbed by living things and incorporated into their tissues. The most bioavailable and most toxic form of mercury is called methylmercury, abbreviated as MEHG. Once a plant or animal has methylmercury in it, whatever eats it essentially inherits that mercury, causing animals higher on the food chain to have higher concentrations of mercury. Primary producers like phytoplankton contain 1.5 to 8.2 parts per billion methylmercury. Levels in marine fish have been shown to vary between 57 and 377 parts per billion, and fish living deeper than 300 meters had 4 times higher mercury concentrations than those closer to the surface. Mercury pollution in the ocean poses a serious threat to the health of humans who rely on the ocean as a food source, because just like other animals, humans inherit the bioavailable mercury from the food we eat. Once it's in our bodies, mercury is a potent neurotoxin. Mercury gets into the surface ocean in one of 3 ways, either through atmospheric deposition, when mercury literally rains out of the atmosphere, through rivers emptying into the ocean, or from deep ocean waters rising and bringing mercury to the surface. There is an estimated 6,000 tons of mercury in the atmosphere, and over a third of that is anthropogenic. Atmospheric deposition brings 10 million moles of mercury per year to the global oceans, while rivers bring 1 million moles, and deep ocean waters bring just 0.5 million moles of mercury to the surface oceans. Mercury that enters the ocean from atmospheric deposition either has an oxidation state of +2 or 0. When mercury in the atmosphere has an oxidation state of +2, this is reactive gaseous mercury. Mercury with an oxidation state of 0 is called elemental mercury. Reactive gaseous mercury is formed when elemental mercury reacts with compounds like chlorine and becomes oxidized to form mercuric chloride, or with oxygen when it forms mercuric oxide. We will call reactive gaseous mercury that ends up in the ocean divalent mercury, and some of this divalent mercury sticks to particles. Elemental mercury can also stick to particles, but it must first be transformed into divalent mercury, either by sunlight or bacteria. The particle sinks to an anoxic part of the ocean, where sulfate-reducing bacteria convert the divalent mercury into methylmercury. The methylmercury is subsequently transported to the surface layer, where most of it is incorporated into the food chain. The rest is reduced to elemental mercury by sunlight or bacteria, and can either begin the methylation process again or be released into the atmosphere. Elemental mercury is the largest pool of mercury in the ocean, and an astounding 1% of all ocean mercury is released to the atmosphere every day. We can also see from the diagram that the speed of the particle sinking can determine the rate of methylmercury production. The ocean today has varying mercury concentrations in different areas. We usually see highest concentrations in the Mediterranean Sea, around 2.5 picomoles per liter. The northern Atlantic was found to have 2 picomoles per liter, and the Antarctic Ocean has the lowest concentration at just 0.8 picomoles per liter. The overall average concentration of mercury in the ocean today is around 1.5 picomoles per liter. When we find very high levels of mercury in a small part of the ocean, this is usually because a lot of mercury was dumped into a river and was washed into the ocean. Before anthropogenic alteration of the mercury cycle, average surface ocean concentrations were 0.16 picomoles per liter. Overall, 80 to 83% of all ocean mercury is there because of humans. By the year 2100, methylmercury will have increased in polar regions and will affect life there as it does in other regions today. About 1/8 of the Arctic population is indigenous peoples, spread across 3 continents. Because of the colder climate and shorter growing seasons, more of these people's diets comes from meat, like fish. Ocean methylmercury concentrations increasing could disproportionately impact the Arctic population. Mercury is always cycling through the ocean, but with the anthropogenic practices we talked about in this video, the amount of mercury in fish and in humans is becoming alarmingly high. The longer we wait to slow or end unnatural mercury emissions, the less effective the eventual reduction will be. We need to limit mercury emissions quickly if we want to reduce Arctic mercury concentrations and improve the health of humans all over the globe.